In this video, we're going to talk a little bit more about probability. And we're going to use something called the fundamental counting principle. Right? And all this really is fancy counting. Basically, we're going to use the fundamental counting principle to help make counting easier. Alright, so let's look at an example. You flip a coin 4 times in a row. What's the probability of getting no heads? Okay, the probability of getting no heads if we flip a coin 4 times in a row. Right, before we actually start this, I want to write this out in words. What are we actually going to be counting? Right? So if I want to figure out the probability of getting no heads, how would I calculate that? Right? Well, remember our definition of probability. The probability of an event happening is the number of ways our event can happen out of the total number of outcomes. So how many ways can our event happen? In other words, how many ways can we get no heads? Right? That's what's going to go on top. The number of ways for our event to happen, or the number of ways to get no heads. Right? And the bottom is the total number of outcomes, or in other words, the total number of ways to flip a coin. And not, sorry, to flip a coin 4 times. Okay? So the probability of getting no heads is the number of ways to get no heads out of the total number of ways to flip a coin 4 times. All right, let's think about this bottom number. How can we count up the number of ways to flip a coin 4 times? Right? And there's kind of a long way and there's kind of a short way. So let's think about the long way first. How many ways are there to flip a coin 4 times? Well, we could count. One way would be we could get heads, 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 heads. A second way would be we could get heads, 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 tails. Or maybe we get heads, heads, tails, heads. Or maybe we get heads, heads, tails, tails. Right? You get the idea, right? I'm not going to write all these out. Right? It just would take a long time. So there's got to be an easier way to count all these up, right? So this would continue. But how many of these are there? How many ways are there to flip a coin 4 times? Right? And so there is an easier way to think about this. Okay? To illustrate this, I'm going to kind of use what's called a tree diagram. So imagine we flip a coin. All right, so imagine we flip the coin just once first. Well, what could happen? We could either get heads or we could get tails. Well, so how many different outcomes are there? There's 2, either heads or tails. Okay. Now let's think about what would happen if we flipped it a second time. If we flipped it a second time, well, if I got heads the first time, on the second flip I could either get heads or I could get tails. Same thing, if I got tails the first time, I could either get heads or tails on the second one. Okay, so now if we flip 2 times, how many outcomes are there? There's heads, 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 tails, tails, heads, and tails, tails. So there's 4. We start out with 2, and then each of these 2 branched off into two more branches. Well, now let's do it a third time. We've got 4 outcomes now. Let's flip it a third time. Each of these is going to branch off to 2 more again. Heads, tails, heads, tails, heads, tails, heads, tails. It's getting kind of small here, but you guys get the idea, right? So we could have heads, 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 tails, or I'm sorry, heads, heads, tails, or heads, tails, heads, tails, 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 etc., etc., right? So we start out with 2, then for each of those we had 2 more, so we have 4 now, and then for each of these 4 we have 2 more, so now we have 4 times 2 is 8. But we've only done it 3 times. Now we've got to flip it 1 more time. We've got to flip it 4 times in a row. So if I were to flip again, each of these could either be heads or tails. Heads or tails. Heads or tails. Right? I'm not going to write all these out. But you guys get the idea. Right? So here we had 8 outcomes, and then for each of all of these 8, they're going to have 2 more, so we'd have a total of 16. Right? So there was 2 possibilities the first time, and then each of those branch to 2 more, so now we have 4, and then each of these branch out twice, so we have 8, and then each of these branch out to 16. So we could count this by doing 2 times 2 times 2 times 2, which is 16. So that's the bottom of our fraction. The number of ways to get, or to flip a coin 4 times, there's 16 ways. Right? And the shortcut is to do this 2 times 2 times 2 times 2. Right? Well, we still need the top of our fraction. How many ways are there to get no heads? Well, this is kind of an easy question. How many ways are there to get no heads? There's only one way to get no heads, right? The only way to do that is to get tails, 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 tails. So our fraction would be 1 out of 16. All right, let's look at another one. You roll a die 3 times in a row. What's the probability that you would get the same number 3 times in a row? All right, again, I want to write this out in words. So the probability of getting a number 3 times in a row. All right, sorry, this is kind of messy. All right, so what would this be in words? Well, it's going to be the number of ways to get 3 in a row, right? Or I should say the same number 3 times in a row, right? Over the total number of ways to roll a die 3 times. Okay? All right, so let's go ahead and think about how we could count these. Right? Let's first figure out the bottom. How many ways are there to roll a die 3 times? Okay, well, what if we roll it first? What could happen? We could either get a 1, or a 2, or a 3, or a 4, or a 5, or a 6. And then so now there's if we roll it once, we have 6 ways to do that. But then for each of these, after that, for the second roll, I could either get a 1, a 2, a 3, 4, 5, or 6. Right? And I'm not going to draw all these out, but I want you to see what happens. Right? Each of these would have 6 more branches. So 6 initial branches, and then 6 more branches. 6 times 6 is 36. And then for the third roll, each of these 36 is going to have 6 more branches. Right? Each one of these is going to branch out 2, 3, 4, 5, 6 times. So how many would that be? We'd have 6 initially, and then each of those 6 have 6 more branches. And then of those 36, each of those is going to have 6 more. So 6 times 6 times 6. 216. There are 216 different ways to roll the die 3 times. Well, now, how about our top number? How many ways are there to get the same number 3 times in a row? Well, we can kind of list this out. We could get 1, 1, 1. That's the same number 3 times in a row. Or we could get 2, 2, 2. We could get 3, 3, 3. 4, 4, 4, 5, 5, 5, or 6, 6, 6. So how many ways is that? 1, 2, 3, 4, 5, 6. So our answer would be 6 out of 216. And you can reduce that, but for the sake of this video, I'm not going to do that. Okay, one last one. And this one I'm going to see if you can kind of finish it. All right, let's say a restaurant has a new dinner special. For $15, you can get an entree and a side. For your entree, you can choose between a lobster or a steak. The available sides are potatoes, vegetables, rice, french fries, or coleslaw. Your friend orders for you. Let's say you're late, so your friend has to order for you. And since he doesn't know what you like, he just chooses randomly. Right? He's going to pick an entree, pick a side at random. But you know what? Your ideal dinner would be steak and vegetables. What's the probability that you're going to get what you would want? All right? So let's think about this in words. The probability of getting what you like, right? Or I could say it this way. The probability of getting what you like is steak and vegetables, right? Probability of getting steak and vegetables is going to be the number of ways to get steak and vegetables, I'm going to abbreviate there, over the total number of orders that are possible. Okay, so let's try to figure out these two numbers. All right, so actually I would like you to pause and see if you can figure out how many ways there are to get steak and vegetables and how many ways there are to get, or how many total orders there are possible. Go ahead and pause and see if you can figure it out. All right, let's see what you got. So how many ways are there to get steak and vegetables? Well, there's actually just one, right? You order steak and vegetables. The bottom is the one that's more interesting. How many total orders are possible? Okay, well, let's think about this. All right, I don't want to write these all out, but we could get steak or we could get lobster for the first choice, right? And then if we choose steak, we could choose, what could we choose? Potatoes, vegetables, rice, French fries, or coleslaw, right? So for each one of these, they're going to have 5 branches. So there are a total of 10 orders, right? Because 2 choices here, and then each of these choices has 5 choices. So 2 times 5, we have 10. So our probability of getting steak and vegetables would be 1/10.